position, path, length, and displacement. So that's the So lower class scalar quantity, vector quantity. Scalar means it has only magnitude, that is called scalar. It has both magnitude and direction quantities are called vector quantity. So now we are going to study about the position, path, length, displacement, that thing. Okay. So in this lesson now we are going to see the position. When the force acting on the object, it will move with the velocity. So without the force, it has no velocity. So position of the body. Depending on the position of the body, we can define that whether it is in the rest or in motion. So we can define the position of the particle by using the three Cartesian coordinate axes: x-axis, y-axis, and z-axis. So depending on that, we can locate the position of an object. So using these three axes are called Cartesian coordinate axes. Already you know that. Okay. So it is the origin. All the three axes are intersect there. So that point is called O. So all the angles, that is x-axis, y-axis, z-axis, are perpendicular to each other. So these are all the axes x, y, z. It's a clockwise direction. You know the two different type of axes, clockwise and the anti-clockwise. It is an origin, or it can be called as reference point. So now you can see that in a three-dimensional picture: x-axis, y-axis, and z-axis. Suppose the particle is moving in the three-dimensional motion, that is called the three-dimensional motion. So now you can see the position of the particle depending on the three axes: x-axis, y-axis, and z-axis. And you know that how to define the position of the object. Now you can see that the object is moving along the y-axis. So you can consider that car. So now we are going to consider the three axes in the three road. So it is moving in the x-axis, y-axis, parallel to the y-axis, or it can be z-axis. It is moving in the parallel to z-axis. So on the basis of, we can define that xy plane. The car is moving xy plane. So this is xz plane, and this is zy plane. So because we are defining the position of the particle by using the two axes. Now you can see the motion of an aeroplane. So it is a curved path, and at the same time the height also increases. It's called three-dimensional motion. So that is an example for the three-dimensional motion. So body at rest. So depending on the time period, there is no change in the position here. That's called a rest. So depending on the time period, the body is moved from one place to another place. That's called motion. So by using the Cartesian coordinates, that's also called as frame of reference. We can define the position of the body. Now you can see that the body in motion. So body is moving with velocity. So that is the origin point. The man sitting inside the car is taken as origin. The car is moving the parallel to the x-axis. So this is the fixed point O. That horizontal component is x, vertical is y-axis. So we can, using these two components, we can define the position of the particle. That is fixed point O by using that man. That frame is called a frame of reference. So now you can see that x and y. The car is moving it along the x direction. Now you can see that. So y direction, x direction, y direction, or it can be moved the z direction. Z direction is the example for the flip. So the car is moving like this type of path. By using this, we can define that distance and the displacement. So this is the example for the three-dimensional motion. So all the three axes, most of the particle in all the three axes: x-axis, y-axis, and the z-axis. So see that rectilinear motion. That means particle moving in a straight line. That type of motion is called a rectilinear motion. So origin O to that x, that is the displacement of the car. So it is moving from the point O to x, straight line. That is a rectilinear motion. So that is called the distance from point O to parallel to y-axis. So it's the positive side of the x-axis, and this is negative side of the x-axis. The same thing for the y-axis also. Positive side of the y-axis and negative side of the y-axis. That is negative value. Okay, so these are all the four sides. And z-axis. So x, y, z. So this is where we can define the position. You can consider that man marking the x-axis. The distance traveled by that man, then the x-axis, rectilinear motion, straight motion, depending on the time period. From point O to, that is, you can see that how initial position is, origin is O, the distance equal to 0, time period equal to 0. After the time period, it displays the position from O to A. The distance traveled by the object or the man. So that is indicated by the blue color arrow mark from 0 to A is a 36 meter. That is path length. It's called a path length. The path length is also is equal to the distance. So it travels from the point O to A. Then he turned back in the opposite direction move from A to B. So now the path length equal to, path means you know that actual distance traveled by that object. That means you have to add the two values. That is the actual distance OA plus AB. So you will get the total value of 48 meters. 46 plus 12. So this is called the distance. Actual path traveled by an object is called distance. Okay, that is also called path length. That's also equal to path length or equal to distance traveled by the body. So path length and distance are equal. Then displacement, change in position of the body. So here displacement has the direction. In path length you are not considering the direction, but displacement you have to consider the direction. Yeah, see, you can see that object, it's a point of origin O. It's moving the distance of x1 and x2 or the two positions for the time period of t1 and t2. Initial time period is 0. So the change in time period, the change in distance is delta x. So change in time period t2 minus t1. That is the change in time period. Okay. So using that, we can calculate the displacement. Delta x is the change in displacement. x2 minus x1. Delta means that is change. So positive means that this value x2 is greater than x1 means that is a positive value. Suppose x2 is greater, that is negative. X1 is greater, that is negative value. So depending on that, the displacement indicates the direction, whether it is a positive or negative. Okay, positive means it is in the positive side. Negative means it is the negative side. So displacement, that magnitude is depending on that value. So the arrow mark indicates the direction. The length of the arrow is indicating the magnitude. Now you can consider that point, that man traveling from the distance from point O to the point A in x-axis. That distance traveled by the object is 36 meters. Okay, that is delta x changing from 0 to 36. So difference between 0 and 36 is 36. So it is positive side. Suppose he is moving from point A to B in the opposite direction. You can take the 12. In displacement, you have to consider the direction. So 12 is a minus 12. It is in opposite direction. So we have put minus 12. So from point A to B is a negative direction. That is minus 12. So what is the path length means? It is 36 plus 12, 48. So it is not equal to displacement because displacement OA equal to 36. That is path length. Actual path length. The displacement is here also, that is 36. Then the object is moving from O to A, but it's going from A to B. That 12, that is 12 in the opposite direction. So it gets negative side. So actual displacement is 24. Path length is 48. So initial and the final point. So initial point is a 0. Final point is another one. The 2 points are equal means that means magnitudes are equal, opposite in direction. So definitely that value becomes 0. So for an example 0 to A, you can consider that value is traveling in that 36 meters. The same time he is traveling from the point A to O. That is also 36 meters. So what is the path difference means? We have to add these two values. But displacement is 0 because displacement is the shortest distance between the instant final position. So he is in the same position, that is 0. So body at rest and motion is depending on the time period. Okay. So depending on the time only, we are going to derive all the values. Now You can consider that car, initially it is in the rest position. It's moving with the velocity v, so it will travel the distance depending on the time period. So distance is 40. So when the time period is increased, it's moving in a constant velocity. So you will get the straight line. So the distance is traveling, initial distance is 0. See, that car is traveling from 0 to 40 in an equal interval of time, in equal distance. So you can get the straight line. So you will get the straight line. For the corresponding time period, 10, 15, 20, 25, 30, you can find out the distance traveled by the object, 20, 30, 40, 50, like that. So now you can see that the car is moving in the same that velocity, but see that initially it is started, accelerated, and it is slowed down. Finally, it comes to rest. So that arrow mark, that see the curve, how it is drawing in the graph. Initially, it is accelerated. So that line is increases, then uniform motion. Finally, the velocity decreases and it comes